Sound speeds. And if you're like me, you get very annoyed by all the different and inconsistent methods that microphone manufacturers use when providing you specifications on their data sheets. Let's face it, we're creatures of habit and we like to see things listed a way that we understand. And not all microphone manufacturers do things the exact same way. So in this video, we're going to go into candid mode and look at the computer, and I'm going to show you how to calculate the specifications that you recognize from the ones that they provided you. For our purposes in this video, we're going to be looking at some of the specifications of a few of my favorite microphones, and a few of the more common microphones that you'll find online, either or maybe even both. But in case I don't mention it later, if you've ever watched my video called A Lesson in Microphone Sensitivity, some of the information I'm going to be giving in this video is paralleled and elaborated on even in that video, and vice versa. So if you have not already watched that video or you want a refresher, be sure to click on the link down in the description below that sends you to that video, or click on the link at the end of this video and it will take you there so you can watch it. The first of two simple formulas I'm going to show you only affects condenser microphones, and the reason why is most dynamic microphones are what's referred to as pressure-operated microphones. More in that video right there. But pressure-operated microphones basically use the vibrations in the air, or acoustic energy, and turns it directly into electric energy. And it's a very, very low level and requires amplification for you to do anything with it. And because of that, normally you're not going to see a maximum SPL level. More in this video right here. And there's also not normally a noise floor or equivalent noise level on that microphone either. But it does have a resistor in there with a certain impedance load. For example, 150, 200, 300, whatever the impedance of that resistor is in ohms is going to give you the self noise of that microphone if your preamps were perfect. Now, preamps play a big role in it too, because some are cleaner than others, some are dirtier than others. And those preamps, if it is not extremely clean, is going to provide a lot of noise in your microphone output signal. So when we're looking at this formula that basically affects condenser microphones, because condensers are basically microphones that are then amplified through phantom power, 48 volts, it has maximum SPL minus dynamic range equals the equivalent noise level, or the noise floor of the microphone, in decibels A weighted. The second formula we're going to go over affects all microphones, and that is sensitivity in decibel voltage minus the signal to noise ratio equals EIN, or equivalent input noise. Let me go over what EIN is. In the world of digital audio, 1 volt of current is what is basically produced at 0 dB of level. And in case you didn't know, line level in the professional world is plus 4 dB, or 1.228 volts, and consumer line level is negative 10 dB, or 316 millivolts. Now, line level is a lot hotter than mic level. Mic level is considered negative 40 dB, or 10 millivolts, down to negative 60 dB, or 1 millivolt. Even though microphones can be more or less sensitive than that range, that's considered to be mic level. Now, EIN is basically the decibels associated with that millivolt level. So the lower decibel it is, the lower the noise is. Now, let's see this in action here. If we're going to be looking at, we're going to use the Rode NT1 for our first calculations here, because the levels are very easy to, the specifications are very easy to look at and calculate with. I'll show you why. Even though it only gives us 1, 2, 3, 4, 5, 6 is what we would like to have, it only gives us 1, 2, 3 of those specifications. But we can do some calculations with those, and they're very easy at that. Maximum SPL, or 132 dB, minus dynamic range, which we don't know what that is, equals the equivalent input noise, or rather the equivalent noise level in dBA, which is 4 dBA right there. And basically dBA in this case, equivalent noise level, is if you had a completely dead quiet environment, which was 0 dB, some sort of a test chamber, let's say, this microphone would give off it would be able to hear noise at a level of 4 decibels A weighted, which corresponds to the human hearing frequency curve. So this is A weighted to 4 decibels. So as long as you are in an environment that is at least 4 decibels in volume, you're not going to hear that noise floor, provided that the environment sounds the same as this microphone picks up. And this microphone is flat, so hopefully it would pick up about the same as your ears would. But if you increase the gain then this noise floor goes up as well. Just like if you decrease it because you're speaking very loudly into the microphone, then this goes down to the abyss. It goes down below 0 dB and you'll never hear it. So that's a little side note here. Now let's look at the other formula. Sensitivity, hey, we know what that is. That's negative 29 dB minus signal to noise ratio equals EIN. Don't know anything about that. Now, real quick regarding sensitivity, 1 volt per Pascal. It basically is creating 35 millivolts of current at 94 decibels. Okay, what does that mean? 1 Pascal is the amount of pressure is created by 1 Newton per square meter. A Newton is considered to be the amount of pressure it takes to move a 1 kilogram object a meter every second. So ongoing, so per second. So that is a very little amount of pressure that is basically having to create a 1 volt amount of current. And that would basically equivalent to the acoustic pressure, energy that is created by 94 decibels. So 94 decibels, the fictional microphone or the hypothetical microphone that is able to create this kind of output would have to be listening to an audio level of 94 decibels to create 1 volt of output current. And that hypothetical microphone at negative 29 decibels is able to be as sensitive as this microphone. So that said, the sensitivity level is in decibels. So right here, sensitivity, negative 29. Now this here, based on those 3 specifications, believe it or not, we're actually able to do quite a bit with our calculations. Let me show you how. To help you visualize the calculations before we just pull out a calculator and go for it, I've created 2 rulers here in Photoshop. The first one is sound pressure levels in decibels, starting at 0 dB and going all the way up to 150 dB with 94 decibels in red. The other one is the output voltage, which is EIN basically, 150 going all the way up to 0. Now let's plug in some values here. 132 is our maximum SPL, and our noise floor is 4 right there, right? So why don't we go ahead and just create a little box going from 1, 2, 3, 4, all the way up to 132 decibels. So there is a box that represents the dynamic range. Now I'm going to put this aside for a second. And the reason why, actually, let's just make it invisible. And the reason why we're going to do that is because if you look at our specification sheet right here, it says 94 decibels equals a negative 29 dB sensitivity. So let's actually plug that in. This is our sensitivity. This is negative 29 dB, and we're going to make it even right here to 94 decibels. So now let's bring back our dynamic range, and we're going to match it up. Well, actually, let's make it a little more visible here. We're going to do that right there. Okay, so now we're going to take our dynamic range and we're going to overlay this where it's supposed to go, which is 132 dB all the way down to 4 dB, or as it corresponds to down here, 100, or negative, I should say, 129 EIN. See how that works? And just to confirm our results here, just to make sure that it actually works, because this is basically right here, and just so you know, the decibel level here, negative 29 dB starts right here. This negative 29 going down to negative 119 is our signal to noise ratio. So that number right there is basically, if you look at our calculations now, whoops, let's go right here. Sensitivity, negative 29, minus something equals the equivalent input noise of negative 119. So that obviously is 90. And just so you're aware, let's just confirm our calculations. 90 plus our self noise of 4 dB is going to create 94 decibels. That's another way to look at it. Now, let's actually plug this in an actual calculator. Let's bring up our Rode specs here for a second with our calculator. So 132 decibels of dynamic range minus 4 equals 128. Now 128, I'm going to freeze for a second. 132 maximum SPL minus what number do we need to get down to 94 decibels. So it's 38. So we're going to take 38 and subtract 38 decibels from 128, our dynamic range, because that basically starts at 132 and goes down until we get to 94 dB. That gives us 90. There's that 90 again. Negative 29, negative, minus 90 decibels equals 119. That's correct. So there's our math confirming. So basically, the EIN for the Rode NT1 is going to be negative 119. That's a very low level. Now, let's play with this, the same exact thing in a few other circumstances. But first, actually, let's confirm this on the specification sheet itself, which is right here. The equivalent noise level we know is 4.5 dBA. It actually just rounded down on the other sheet right here. If you look at it, it loves to do that. So negative 4 dB and negative 29 dB. Remember, our dynamic range is 128. We calculated right there. Signal to noise, we calculated at 90, and it doesn't give you an EIN rating. So there you go. We've calculated those numbers, and you see it all matches and jives great with the specification sheet. So we know the Rode NT1 is correct. So let's go ahead and plug it into another microphone that was used in my sensitivity video, and that is the AKG C535EB. Now let's do some calculations here. Our maximum SPL without the 14 dB attenuation pad enabled is 130 decibels. So we'll plug that in there. Subtract from that the self noise of 21 decibels, and we have our dynamic range of 109 decibels. We'll come back to that in a second. Now 130 decibels is our maximum SPL. Now how far away in decibels is that from 94 dB? That is 36. So we're going to take 36 and we're going to subtract that from our dynamic range to create our signal to noise ratio. And basically 73 decibels below our sensitivity of negative 43. So let's do that math right here. Let's take this right here and we're going to subtract from that 43, and we have 116 decibels. Now, 116 is the EIN. So there you go. We've calculated all of the specifications for the EV, or the 635A, the AKG 635A. So we basically created all the specifications from this right here, which is basically only a maximum SPL, equivalent noise level, and the sensitivity. Again, the sensitivity wasn't even in the right format here. Now, just like in our lesson in microphone sensitivity video, we're going to now look at the SM7B. Now, it is a dynamic microphone, so remember that it's not going to have any of these specifications up here. But that means that we can still use it to, we can still kind of calculate them using a few other things here. I'll show you how. Now, let's look at what it does give us. Well, it gives us a negative 59 decibel of output level, but it doesn't tell us anything else except 150 ohms. So I'm going to show you something here. Sound Devices makes a bunch of really awesome audio equipment. And one of the things it specifies inside of its technical sheets is why it uses the input impedance noise. And it basically goes over that. And in this video document, it actually, or not the video document, but inside this document, it tells you that 150 ohms generates negative 133 dBV. So let's plug in now that value, negative 133, 33 dBV is the amount of noise that is given out by a 150 ohm resistor. So 133 decibels minus 59, that's going to get us the signal to noise ratio of 74. So based on this 74 right here, we're going to plug that in at 94 decibels. 94 decibels minus this right there. Signal to noise ratio is going to give us a 20 dB of self noise on an SM7B. Now let's do some calculations for the T.Bone SC400, which is a microphone I reviewed, and you can watch that review right there. We have an maximum SPL of 132 minus the equivalent noise level of 6.7, and that has now calculated to be a dynamic range of 125.3. But in this case, it also gives us the signal to noise ratio right here, which we know to be at this sensitivity level. So at 32.6, or that's negative 32.6, minus the signal to noise ratio, 87.3, that gives us negative 119.9 equivalent input noise. That's pretty low. So based on the specifications it gave us, we can calculate all of them. Now let's look at another microphone that's very popular in the world of podcasting, and that is the Sampson Q2U. According to the specifications, it only gives us some things like a maximum SPL, which is kind of weird to have on a dynamic microphone. So it's obviously not a full-fledged pressure-operated microphone. But that's probably because it is a hybrid. It is an XLR and it's a USB microphone. Therefore, when it's powered through USB bus, it does kind of have to amplify the sound a little bit to itself. But it still has the same sensitivity that it would as a normal pressure-operated dynamic microphone. So let's just, for sake of argument, we're going to assume that it has built into it a 150 ohm resistor, just like, many other common dynamic microphones. So based on the specifications we see right here, which is the sensitivity of negative 54 dB, let's try to figure out the self noise. Well, we know the maximum SPL. We know nothing else in that entire category, but we do know the sensitivity is negative 54 dB. So what can we calculate here? Well, remember that 133 decibels EIN is what the equivalent input noise level is for a 150 ohm resistor. So let's start with that. Let's subtract from that the sensitivity of negative 54 dB, creating a signal to noise ratio of 79 decibels. Now we know that 79 decibels, this is basically 79 at 94 decibels, so we can easily plug this in by saying 94 decibels minus 79 equals 15 dB of self noise. Now we know that the 15 dB of self noise, now we know what the signal to noise ratio is, and basically all we have to do now is take this right here and subtract 15 from the maximum SPL, and we know now our dynamic range is 133 dB. It's kind of interesting that it matches the EIN of the 150 ohm resistor. Kind of cool. So to make sure we fully understand our formulas, let's do a couple more practice calculations, starting with the Sennheiser Engage 416. The maximum SPL, 130 decibels, minus the equivalent noise level of 13, gives us our dynamic range of 117. Now our maximum SPL is only 36 decibels away from 94, so we're going to take our dynamic range of 117, subtract from that our 36 decibels to get down to 94 dB, and we see our signal to noise ratio now is 81. Now, if we look at our sensitivity, it's listed in millivolts per Pascal, but nothing in decibels. So let's plug in 25 millivolts per Pascal, hit calculate, and we have a sensitivity of negative 32 decibels. Let's plug that in now. So 32 minus 81 signal to noise ratio, and that's actually one of the higher EINs we've seen, negative 113. But it still sounds good on that mic though, doesn't it? All right, last example, the DPA 4017B, my favorite microphone. We have a maximum SPL of 138 dB. We're going to subtract from that the dynamic range of 124 decibels, and that gives us an equivalent noise level of 14. But if you notice here, it's listed as 13 typical and a maximum of 15. And so I guess they kind of just throw it in the middle there. So you see the specifications are sometimes a little on the confusing side. Now, let's go ahead and look at one more thing here. 138 decibels minus what number will get us down to 94 dB? That's 44. Well, we already have a dynamic range here of 124, so why don't we just go ahead and subtract 44 from that, giving us our signal to noise ratio of 80. And because our sensitivity is negative 134.44, 34.4 minus the 80, and we have an EIN of 114.4. Look at that. So in every one of the microphone examples we just looked at, we were able to calculate the missing specifications from the specifications that we were given, with the exception of the Sampson Q2U, and it's probably because it's some sort of XLR USB hybrid. But we did assume for our purposes of calculation that it had a 150 ohm resistor on the inside, just like the SM7B. And that's probably inaccurate, but if you'd like to measure your Q2U and write down in the comments below what the actual ohm measurement is on it, I would certainly love to see it. But I would like to add one more thing. When you're doing calculations without real-world measurements, I recommend using real-world values. Like, for example, the EIN of the 150 ohm resistor we were just talking about is actually, by definition, 133 EIN. Negative 133 EIN. And even if you measure your microphone specification to be lower than that, I wouldn't recommend using that because the actual resistor itself has a noise level of 133 dB. But on that note, you know what? It could be slightly off, so your measurement could be accurate. It's up to you to decide. But keep that in mind because all of this is a bunch of sound advice. Have a question you'd like answered or want to add something? Be sure to write it in the comment section down below. You can also make a suggestion for future topics of discussion. Again, comment section down below, or you can email me at soundspeeds@yahoo.com. Be sure to subscribe and turn on notifications so you won't miss out on future sound advice.